Hey guys, David here and welcome to another video. I've been using my Voron 0.1 for about 2 months now and I've printed a bunch of stuff. I've tried all kinds of different materials like the common ones, PLA, PETG, ABS, but also some nylon, some polycarbonate and also some flexibles. I also have, as you can probably tell, made quite a few modifications and improvements to the printer over the kind of stock build that they recommend, just to make my life a bit easier and enable some other things. I also experimented with printing extremely fast, went ahead and participated in the speedboat race and printed some extremely fast benches. I'll tell you all about that later. And I also even played around with some big nozzles and just pushing the flow rate that this Dragon hot end can deliver to the absolute maximum. But before we get started looking at the upgrades, I want to give a big thanks to PCBWay for sponsoring this video. They make super high quality PCBs that are very affordable and make prototyping a breeze. For just $5 you can get 10 PCBs up to 10 by 10 centimeters, double-sided, silk screen everything, which is a great price for prototyping. And if you are looking for 3D printing services, even exotic stuff like metal and kind of powder bed fusion and stuff like that, make sure to also check out their manufacturing services. All of that stuff is of course linked down below. And with that, I want to get into the upgrades to this printer. I first wanted to build it stock, as this allows me to follow the manual, and if anything goes wrong, there's a lot of support on the Discord server. With stock builds, it's very easy for them to figure out what's going on, because hundreds of people have already built these printers and they really know where the kind of hiccups are. But if you want to know more about my initial build experience, you can check out my previous video. This is more about what came afterwards. The very first thing was, of course, to print a little serial number badge. Mine is V0.751. But after that, I moved on to slightly more mechanical upgrades, if you want to call them that. And the first one I did was I added some LEDs to kind of illuminate the enclosure a bit, as it does get quite dark in there. Especially since I then later added a bunch of insulation to it. Now, just stock, the kind of plexiglass windows around give it already a good enclosure that keeps a lot of the heat inside, which is great for printing ABS. This basically means I have no issues with ABS warping. I've printed basically full build volume ABS parts with no cracking, no warping whatsoever. But for printing stuff like polycarbonate, I did want a bit more. Before I could maybe reach around 50 to 60 Celsius inside the enclosure. So I just used some packing foam that I had left over from a bunch of lasers and whatnot that got shipped to me, and it happened to be that one of the sheets was black and exactly 15 millimeters thick. This is ideal since the extrusions used are also 15 millimeters, so I could just cut out some squares and fill them into the sides, just push them in, no glue required, and it looks absolutely beautiful. It looks like it was designed with that in mind. Some of the other parts were not quite as straightforward. I also added some in the back, and then for the top hat, which is where kind of most of the heat was escaping, on the sides I was able to put it inside of the top hats as there is enough space, but the back and the top, they really need the full space so that the cable has enough places to go. So I went ahead and put kind of a hat on top and reaching down the back that I can just kind of put on there if I need it, or take off otherwise. With all of those foam pieces in there, the clear acrylic side panels also did not look too great anymore. So I went ahead and spray painted them with a matte black and added a little logo on the side as well, just because I can, and it looks really cool. For the back, I actually made an entirely new panel, and that is because the stock panel is just a flat panel, which does not give a lot of ventilation to the electronics. And especially with the chamber heating up, the first thing I noticed is that my Raspberry Pi was giving me overheating warnings, and it was not really working all that hard. It was just that it was in a hot enclosure. So what I did first was I just cut some holes into the stock panel and added a little fan for the Raspberry Pi, and that completely solved all of these issues. But I then later also wanted to give some more airflow to the mortars themselves. So I decided to actually use that as an opportunity to use my new Retric CNC for the very first time. And I cut out a new panel out of some acrylic with some nice little hex pattern holes around the motors and also over the motor drivers, and with, of course, the fan cut out for over the Raspberry Pi. This fan just kind of pulls in some fresh air, cooling over the Raspberry Pi, and then that air gets pushed up around the motors and out those hexagonal holes, which just makes sure that the electronics stay nice and cool while the rest of the enclosure is heated up. I have also ordered a new linear rail for the X-axis actually, but somehow it's been stuck in customs for over a week now, so I decided to just make the video before I upgrade it. And that's because the kind of cheap linear rails that are included, well, they are decent. There is quite a bit of play in there. On the larger Vorons, they get around that play by having two different rails actually, which are both larger, and so there's not really any play in the hot end. But with just the single MJN7 rail, there really is quite a bit of play in the hot end. And while I have not seen any issues with that in printing, the Discord server, there is an entire section about that where a bunch of people are reporting issues with, because it is kind of wobbly, there can be print artifacts. The proper solution for this would be to use a preloaded Hewin rail, but while you can get this directly from Hewin, and they have basically distributors everywhere where you can just send them an email, they'll quote you back how much it costs you to get that single rail. And for me, it was about $100 for a single rail, which, I mean, it's understandable. They're mostly dealing with bigger businesses, but it was a bit too much. So I went ahead and ordered a non-preloaded one off of AliExpress. Original Hewin still though, which should be right about in between a preloaded Hewin rail and a kind of generic, just loosey-goosey one. I'm hoping that this will kind of reduce some of the wobbliness that exists there. I also have reprinted the kind of extruder housing multiple times by now. The very first one I printed with a black ABS, and with that black ABS that I printed most of the parts of, but that ABS was slightly thicker than the nominal diameter, so I had quite a bit of over extrusion, which on most parts did not really matter, but the tolerances on this machine are very tight, and I will get more into that in the very end when I talk about my overall experience. But what this basically meant that after a while, that hot end cooling fan was actually slightly rubbing against the plastic and was just kind of pushing in the wrong way, where it would start making a noise and kind of slow down, and even had at one point where it completely got stuck, and then, well, of course, there's going to be heat creep and everything melting. So I went ahead and reprinted it. Sadly, I did not have enough of the black anymore, so I printed it in the gray, and that worked great. Completely solved that issue. Just having the extrusion multiplier dialed in perfectly for your filament is quite important. And then with the polycarbonate testing, I actually got the enclosure so hot that the fan shroud kind of warped and got bent just because of the heat. I had the heated bed at like 130 degrees Celsius and the hot end at 300 degrees Celsius for like hours on end with the enclosure fully enclosed. So it probably got around 80 degrees in the main enclosure, and right over the heated bed it was probably over 100 degrees, which then just kind of warped the fan shroud a bit. It was not really an issue, still usable, but I decided to give it another go, and I finally realized how it was intended to print that two-color logo without having a multi-material 3D printer. And that's basically you import the model that has both things in one model, and then you into a slicer, you first hide the main body, slice just the logo, and then you go ahead and print that, and afterwards, without removing that from build plate, you print the main body in a different color over it. And it's actually designed in a way where your nozzle will not push those off, although they are multiple layers high. And this then allows you to create this really seamless looking multi-material part on actually just a regular printer, which is quite cool, and I think this just adds a little bit more to it. On the software side, I also went ahead and configured Input Shaper. I first did kind of the manual approach through the manual and got pretty decent results, but then later I got my accelerometer in the mail and I redid the tests. And on one of the axes, I was actually basically spot on with my manual measurement, but the other, but on the Y axis, it did measure some more other resonances. So I went ahead and took the automatic one, and you can actually kind of see the floppy tool head on that data if you look closely. So I think that once I replace the linear rail, I will actually have to redo the y-axis calibration, as I'm pretty sure that it's going to have some frequencies that are not in there anymore. So I guess for high-speed printing, having that stiffer is also going to be a good idea. And I guess this is a great segue to move over to high-speed printing. Now I dialed in input shaper and everything, and kind of started slowly bumping up the accelerations. And what I quickly noticed is that the limiting factor are those small NEMA 14 motors. The motors on the Voron 0 are smaller than your regular 3D printer motors, which are NEMA 17 motors. However, because of the space constraint, it is using NEMA 14 motors. The default amperage for them that I used was quite low, only 0.5 amps, which had them stay completely cool. So I was able to kind of bump up the amperage, and that allowed me to get more accelerations without experiencing any skipping. But I definitely was not able to get anywhere close to the crazy 40K accelerations that some of these guys are running on their speedy printers. But still, running the accelerations at 10,000 millimeters per second squared with everything else perfectly tuned in all the slicer settings and everything, I was able to print a Benchy in under 10 minutes. It took me a couple of attempts, but it worked out. It actually looks quite decent. However, if I want to go any faster, really, I will have to upgrade those motors to probably maybe some LDO motors. I think they have some models that are quite a bit better, but in regular printing that is completely a non-issue. I don't print above like 4,000 accelerations anyhow, so I don't think I will go ahead and replace those motors, as it's kind of a fun exercise to print a super fast Benchy, but that's not really what I built this printer for. It's just a fun exercise and cannot build a Voron and not attempt a sub 10 minute Benchy. I also did just some kind of linear tests where I went around in a circle as fast as possible, basically taking the accelerations out of the equation and just seeing what the maximum print speed is. And I was able to get just around 500 millimeters per second, which is super fast. Now, of course, it's not the 1,000 millimeters a second that 24/7 3D printing is doing, but he also has quite a bit more upgraded and he's using a Bowden setup. So I feel pretty good about my 500 millimeters a second. And after that, just kind of the extrusion starts falling apart. I can actually move the axis up to like 800 millimeters per second without it skipping, but the extruder was just not able to keep up at that point. Also during printing the Benchies, definitely the kind of hot end assembly was at the very limit. I set the hot end to, I believe, 290 degrees Celsius for ABS, which is higher than needed, but you really want to cook that ABS to extrude it fast enough. But I don't think it ever went above 285 while printing, and it was basically 100% heating the entire time. That's just because, well, it was pushing so much plastic out of there. Like, I think I saw peaks of around 40 cubic millimeters of material being pushed out, which is a lot of material, so it just soaked up all the heat, and another limiting factor. But I could of course also upgrade the heating and all of that if I wanted to go even faster, but on a printer this small, that is not really an issue. I also noticed that once again, when I went up to trying a big nozzle, I put a 0.8 millimeter nozzle on there just for kicks. Now, of course, it doesn't really make sense to put a 0.8 millimeter nozzle on a printer this small, as I quickly noticed that my limiting factor was not necessarily even the extruder. Well, of course, that also was pushing the limit. I was pushing like 40, 45 cubic millimeters a minute out of there. But the main issue was cooling. Even with all the panels removed, fans going at 100%, it was basically impossible to cool all of that material quick enough for the next layer to go on. So I was not actually printing at the maximum speed, just kind of limited by how fast I can cool the stuff down. But I still got some neat prints out of it. But I don't think I'll put the 0.8 nozzle on there again on this small of a printer. But if I was building a Voron 2.4 or a Trident, then definitely I would play around with that more, as it is really cool to just kind of push that material out. And in that case, also definitely the high flow hot end that I have on there, it's a Patheos Dragon high flow, is definitely needed if you're going 0.8 millimeter nozzle. But if you are not, which for this printer doesn't really make sense, you could definitely get away with a standard flow. I took the high flow because I just didn't want to be limited by it, but in retrospect, I think the standard flow would have been a better choice. I was able to get all the stringing issues sorted, but it just still has a lot of material that can ooze out and is kind of not necessary. If I were to run into kind of a bottleneck of how much material I can push out, going with the Bondtech CHT nozzle, I think would be the better move, as that's just I can have a higher flow nozzle in there for when I really need it. But otherwise, for the regular printing, the standard flow is perfectly fine. And then finally, what I went ahead to test is different materials. And that's kind of what I mainly wanted out of this printer anyhow. I have a bunch of printers already. They can print PLA great. And while the Voron, of course, does that a lot faster, doesn't really matter that much. What I also wanted is just a printer that I can print ABS all day long, which this is. The default material I've loaded in there is ABS. I almost never print PLA, because to print PLA I actually have to remove the top pad and the door to get enough cooling in there, which then this printer gets quite loud. Printing so fast, even though I'm running Stealth Chop on the stepper motors, it still is relatively loud, and the fans are not the quietest either. Especially the Partcooling fan is quite loud, as it has to be a small fan to fit in there. So definitely a lot louder than my Prusa. So I prefer printing ABS on it, and for that it is great. It handles it like a champ, perfectly reliable. But I also went ahead and tested some other materials. Now, since it is a direct drive extruder, flexibles were no issue at all. Now, it's not it's not like a Ninja kind of flexible material. I actually don't know the hardness of it, since I bought this roll like a few years ago, and it does not say in the box, and the manufacturer no longer sells it. So no idea, but it is kind of medium hardness, I would say, and it printed great. Bumped the speeds down ever so slightly, but not by much actually. It was still printing the flexible faster on the Voron than I print regular PLA on any of my other machines. So definitely a great job. And stringing is also minimal, and that is without retuning pressure advance. I think if I were to retune pressure advance for the flexible material, then I could basically completely eliminate the stringing. Then next up were some tougher engineering plastics, and I have this roll of polycarbonate. Does not say it's a blend, and I don't think it's really much of a blend based on how it prints. So this really needs a lot of temperature, and I've just mentioned already, and I've already mentioned that I melted my extruder housing. That is because I really had to crank the temperatures of everything. I set my limit actually lower before. I had the maximum bed temp before at 120, but I had to raise that to 130 to get it to stick decently. And the extruder I also played around with and settled at around 300 degrees as a good extruding temperature. But with that, I got some decent results. Now, I had to, of course, use a glue stick on the bed, as polycarbonate does not stick whatsoever to the PEI sheet. Basically, it sticks to itself, and that's about it. And the glue stick is kind of a glue, and that made it stick well enough. But even with that, flatter parts, they just end up warping, and that's because although the enclosure was at around 70 degrees Celsius, for polycarbonate, if it's not like some sort of blend, this really is a bit low. You kind of want the enclosure closer to like 90 to 100 degrees Celsius to get proper parts out of it. But the parts I did get that were not had like a smaller section, like the Benchy worked fine, or the Voron cube also worked fine, and they turned out really nice, and you can really tell the toughness. It's kind of cool comparing the same print on like a flexible than compared to like ABS, which is a lot tougher, but quite a bit softer than something like polycarbonate, which is super stiff. So for super stiff parts, polycarbonate is definitely ideal. But what if you want tough parts, but not too stiff? Then we come into nylon territory. And on many printers, you can print kind of carbon or glass fiber reinforced nylon, as that is a lot more dimensionally stable and doesn't warp as much. I actually had pretty decent results printing regular nylon as well. Now, I didn't do that extensive testing, but with a bed at 120 to 125 and the nozzle at 255, I printed this nylon perfectly fine, and there was some warping in the very beginning, but that was just because the enclosure was not heated up enough yet. But after that, it printed pretty nice. I was also using the glue stick with that, and it actually stuck really well to the glue stick, to the point where I even damaged some of the model slightly while removing it. Now, it was not patient enough to wait for the platform to cool down. If I had done that, I'm sure it would have released easily. But it definitely was sticking a lot more than the polycarbonate parts. Alright, so that is most of the testing that I have done. Overall, I think between like 150 to 200 hours on this printer in this 2 months, and that is actually quite hard to achieve. This printer has such a small build volume with fast print speeds that it is basically impossible to get any long prints on it. I believe the very longest print I have done is the skull that is sitting in there right now, and it was around 8 hours. That was with 0.1 millimeter layer height, and I actually forgot to increase the top shells, which is why there are some holes in there. But it printed beautifully out of ABS, by the way, which is why the overhangs are crap, but that's ABS's fault and not the printer's fault. But otherwise, most other prints are like sub 1 hour, like an hour or 2 hours maybe. And when I printed desk rises in there, I was able to get like 6 to 7 hour prints with the more complicated ones. But that's about it. After that, you have filled your build volume, even if you're printing detailed stuff. So I guess that's kind of a neat problem to have, that the print jobs are done too fast, but that's just why compared to like my Prusa, where I have thousands of hours, it is quite hard to rack up many hours on this machine. But during those hours, I have noticed quite a few things. And I want to preface this with that overall I'm very happy with the machine, and considering how much it cost, it definitely over-delivers, and the Voron community has been really great in helping to figure out any issues, but that doesn't mean that it is a flawless printer. Many of these are to do with the kit that I bought and not necessarily the design from Voron, but I will mention that accordingly. First of all, one that's actually from the design, I've mentioned it before, and that is, it is designed with very tight tolerances. Now, this is a positive and a negative. On the positive, that means that this is a tiny printer with a crap ton of features packed in there, and actually a decent sized build volume. 120 by 120 by 120 millimeters for the size of this printer with all of the features it has is very nice. But this also means that the 120 means it is going from the very left edge where the linear rail ends and the wall hits to the very right part where the linear rail ends and it hits the wall. So this needs to be perfectly centered. If you're off by a millimeter, it will hit the wall because there is just 0.5 millimeter of space in between. Same with like the print bed moving down, depending on how you calibrate it. Once if you move down to 120 millimeters, the screws of it will actually start hitting the bottom panel. Also, the top hat is just barely large enough for the bent bone tube and cables to clear everywhere. They are kind of pushing at it when you're in the very back, and I have them at the like minimum length. So if you're in the front corner, it is kind of flat stretched and it could not be any shorter. This also continues to the individual parts, which if printed perfectly, they just work and everything lines up nicely. But if you have any material too much somewhere because you over extruded or something else is going wrong, you very quickly will run into clearance issues. If you print everything perfectly and pay close attention, it's not really a problem. It is just something to keep in mind and just something to pay attention to, that you really do not have much room for error in there. Another area where that is true is in the kind of Z-axis limit switch. Now I actually didn't realize that in the beginning, but it is designed in a way where like the print bed has slightly rounded corners, and where the Z-axis homes, the nozzle is actually over that rounded corner, so it is not on the print bed itself. And this allows the nozzle to actually home slightly below the print bed, and then you kind of have a 0.1 millimeter offset from the homing switch. This is great in theory, but in practice my print bed is not accurate enough for this. Now, this is definitely a problem of buying a cheap kit. If you got a more expensive one, you will probably have a nicer bed. And although it is claimed to be like precision flat aluminum, it is quite bowed, and the bow is very dependent on the temperature. I went ahead and did a manual mesh bed leveling for it, as I considered putting a probe on there, but there's just not really any room to put a proper probe on there. There are quite a few designs for bed leveling probes, but all of them either kind of give up build space or have issues in some other way. So I just did a manual bed leveling for all the different temperatures that I often use, and just kind of saved those profiles. And at ABS temperatures, so like 110 on the bed, there on my bed there is kind of a deviation of about 0.2 millimeters, which is quite a lot. This basically means that without mesh bed leveling, either you will have parts of your print way too far away from the bed, or others are way too close with a standard first layer. This also meant, though, that that 0.1 millimeter of extra headroom before I hit the switch was not quite enough for me to compensate everything. So I actually changed that up a bit and gave myself a bit more headroom, and played with that for quite a while to kind of get it dialed in. And now it's working pretty well, but still, due to it not having any automatic bed leveling, I have to touch the bed leveling screws every like 5 prints or so to kind of readjust everything. And also the manual kind of Z baby stepping, I do kind of change that quite frequently, ever so slightly, to get the perfect first layer. It just kind of requires a bit more finesse. And like my Prusa, I never think about the first layer. It's just always perfect because of the automatic bed leveling, and it's all integrated and works well. But on here, I do have to pay a bit more attention to the first layer of how that comes out. And another part of the heated bed is that I'm not sure whose fault that is. I guess physics' fault. But when you heat the bed, it will reach temperature quite quickly on the readout. But the actual temperature of the surface of the heated bed lags behind quite a bit. When heating up to 110 degrees Celsius, when the software thinks it has reached 110 degrees Celsius, using an IR thermometer, I'm only at around 80 degrees Celsius. Now, it does reach the rest fairly quickly, but what this means is that if you heat up the extruder and the heated bed at the same time, it starts printing as soon as the software thinks it has reached the 110 degrees Celsius. And I had quite a few prints where the first layer did not really work out the first time around because the bed was just still too cool. And then afterwards, I just restarted the print and it worked perfectly because by that time it kind of had reached. Now it's just like if you wait another 3-4 minutes after the software thinks it has reached the temperature, you are getting very close to it. So it's not that big of an issue, it is just something to keep in mind. Also for printing kind of difficult to print parts from ABS where I really need the heated enclosure, otherwise I would get warping, I would preheat the bed before and just kind of let it sit there for a while to preheat the enclosure as well. I also wrote a little macro that moves the bed up and down. I'm not sure quite how much that does, but I did see the power draw of the bed be ever so slightly higher, like 10% higher, with it moving up and down. So I think it is heating slightly more than otherwise, but it's just kind of a nice gimmick. And one very last thing, I've had some issues with the Partcooling fans. The first ones I got immediately failed after just a few hours, and then the replacements are still kind of weird. They work great in the beginning when you just turn them on, but turn on and work great. And then at some point they kind of start working too well. But if you then turn them up to 100%, they work perfectly fine. But if they drop back down to like 90 or 80%, they don't really turn. I'm not quite sure what the issue is there, if it's a software issue, if it's the fans that are bad in some way, but they are the actual fans that are specified by Voron. It's not the cheap ones from the kit. So not quite sure what the issue is with that. If you have any experience with that, you can leave a comment down below. But I've had some parts where they did not come out well because they really needed the Partcooling fan to kick in, and it just didn't. And they failed, and afterwards I redid it and I kind of manually put it to 100% and it worked perfectly. So yeah, just something to keep in mind. Definitely would prefer the design with a bigger blower instead of the two tiny ones, but just space constraints. With that, I believe I have covered just about everything that I can remember about the experiences with the Voron 0.1, and overall I'm really happy with this printer. It prints beautiful, it prints fast, and it can just kind of sit on the side of my desk and look pretty. So definitely very happy with that, and I cannot wait to build another larger fancy Core XY printer, but we'll probably have to wait a little bit. So with that said, thank you guys for watching. Make sure to like, comment, subscribe, all that good stuff. If you have any more questions, leave them down in the comments and I'll get back to you. And with that, thanks for watching and until next time.